Honorable Ted Liu, Honorable Bill Rosendale. My name is Kim Hoang, and I'm from the U.S. EPA Region 9 office in San Francisco. And I'm here to present a summary of a study that EPA had performed in 2008, which the final report came out in 2010. So without further ado, I'm going to just start on the presentation to save the time. Can you just go back? Yeah. So I just want to point out that I'm actually new to the AIR program, and the presentation that you are seeing here was contributed majorly by Marian Hoyer, who is from our Office of Transportation and Air Quality, Arno Den, who used to be in my position and is now retired, and Matt Laken, who's also in my office. Thank you. Next. So I'm going to, in my talk, I'm going to just give a very brief background on lead emissions from piston engine aircraft at the national level, and go into the reason of why we conducted a study at the Santa Monica Airport, and give you a very brief summary of the results of the study and the recommendation that came from the study. I also would like to point out that EPA has a very extensive website on lead and the other major lead sources, and the website is provided there. Next, please. So at the national level, if we're talking about the different sources that contributed lead to the ambient air, these sources came from gasoline for piston engine aircraft, which are not used in commercial passenger aircraft. They also came from metal industries, manufacturing industries, waste incinerators, industrial, commercial, utility boilers. And in 2008, these collective sources emitted 990 tons. And about more than half of that lead were emitted due to the leaded aviation gasoline. And again, about half of that 551 tons is emitted in flight, and the rest of it is emitted in the local flying area around the airports. Thanks. So this is a map of the US where we're showing here about the 20,000 public and private airports and heliports that have aircrafts running on what we call AV gas, which is the aviation gasoline with the leaded aviation gasoline. So in 2006, EPA received a petition from Friends of the Earth requesting us to set up a standard if we find enough information for the endangerment to public health and welfare. And if there's not enough information, that we could start some kind of study. So in 2007, we issued a notice requesting input on a wide range of issues regarding emissions of lead from piston aircraft. And in 2010, we issued an advance notice of proposed rulemaking to let people know that we are studying this issue and we are requesting additional information. Next. So I'm going to elaborate on this slide a little. So when we started looking into this issue, we found out that there wasn't a lot of information about lead emission and concentrations near airports. And so we started these studies to develop a modeling approach to understand better the gradient of concentrations of the lead near airports. And since lead emissions from aircraft and leaded AV gas are federally regulated, the emissions is regulated by EPA, and the AV gas itself is regulated by FAA. And also in light of the petition that I described in the previous slide, we embarked on this study in order to eventually conduct a national scale analysis of the local impact of lead emissions from piston engine aircraft. And the reason that we selected the Santa Monica Airport was actually threefold. We were building upon the information that were collected by South Coast AQMD at SMO, and also there's no other major sources of lead around the airport. And also the airport actually have collected a lot of information that we would need to put into the model. And then the last and very important reason is the airport actually welcomed us to come and do the study, and that's very important. So next. So as I mentioned before, we did the study in 2008, and the study has three parts. We collected very limited monitoring data in air, soil, and dust. And the air data is mainly to conduct a modeling comparison, a comparison between modeling and monitoring effort. And so the monitoring was only done for, I think, a couple of weekends in the summer and in the winter. And again, and also we monitored the soil and the dust, also in a very limited sense, mainly to see whether there's any potential gradient of lead relative to distance from the airport. The second part of the study was we collected a lot of air quality information that we have to input into the model. And those information include the lead inventory for all of the sources within 25 kilometers of the airport, including factors like the aircraft counts by hour, the lead emissions locations on airport property, et cetera. So those type of information are needed to run the model. And the last part of the study is the data analysis. What we did with the model was we actually run the model for every day in 2008, and we did a calculation for what we call a 3-month rolling average and select out the maximum of those 3 months rolling average to compare it to the lead National Ambient Air Quality Standard. So the lessons that we've learned from the air monitoring, these are, from here on I'm talking about the results of the study, that the average lead concentrations in the air were about the same range as what reported by South Coast AQMD from their study in 2006-2007. The concentrations at upwind locations around the West Tarmac were at or below 0.004 microgram per cubic meter. Concentration at downwind locations, which is the East Tarmac area, range from 0.039 to 0.071 microgram per cubic meter. And the concentrations at neighborhood size downwind range from 0.033 to 0.056 microgram per cubic meter. And what we've learned from the air modeling is that on an individual day basis, the modeling results agreed well with the monitored values, and it provides a strong confidence for us to apply the model to other airports. The lead concentrations above the local background levels extended up to about 500 meters downwind from the airport. And the engine run-up check had a significant impact on ambient air, on ambient lead concentrations. And this is important because we had not previously included run-up emissions in air quality modeling. Roadway dust was not a significant contributing factor to ambient lead levels near the airport. So comparing that to the lead National Ambient Air Quality Standard, which was revised in 2008 to a level of 0.15 microgram per cubic meter, and that's a 10-fold lower than the previous value, which was 1.5 microgram per cubic meter. Again, the standard is measured as the maximum 3 months average concentration, and I would like to point out in the description of the study that we did not collect enough the samples over a 3-month period to provide a relevant comparison to the modeled average. The modeled concentrations at 2 locations on airport have a 3-month average lead concentrations above the NAC standard of 0.15 microgram per cubic meter. But I also would like to point out that the reason for that was the monitor that we put at the location on the airport is actually about 75 meters from the location where the model predict the maximum concentration. And that's why what you see from the model is a maximum concentration, and that is from a location that is about 75 meters from where we put the monitor. But when we put the monitor, we didn't know that fact. And I also would like to point out that this modeling value cannot be used to determine attainment status for the NACs. Attainment status can only be shown by monitoring data, and it's a very stringent protocol for providing those monitoring data. And the other point from the modeling effort is that all of the individual days monitoring data were lower than the modeled 3-month average values. The soil and dust monitoring was very limited, and we did the monitoring on airport property, local parks, and at local residences. And the results show that there's no elevated lead on airport property or in local parks compared to the average non-source impacted levels in California. 2 home samples had lead levels above either the EPA or the draft California EPA lead screening levels. And the aviation lead might have contributed to this level, but some other results, but the results show that there might be some other additional sources. So what are the implications of this study for the other airports? The air monitoring and the modeling approaches that we use for the Santa Monica Airport is fully applicable to all of the other local other local scale airports. However, Santa Monica had 1 runway, so if you go to other airports with multiple runways and the prevailing wind directions might require some additional data than what we've collected for Santa Monica. And the recommendation that came from this study for other airports include conduct on-site survey of piston engine aircraft activities, collect hourly activity patterns, use on-site wind speed and wind direction data, use site-specific terrain and land use data, and include stationary sources within at least 20 kilometers. Our current focus and activity, I mentioned before that we had issued an advance notice of proposed rulemaking. So we are pretty much performing the studies that we lay out in the ANPR. The model piston engine emissions of lead at airports to evaluate the impact on local air quality and exposure to lead. And we're also evaluating the data from lead monitors. And we will issue a proposal describing our analysis and our proposed positions on the question of endangerment. And there is an opportunity for public comment to our proposal before any action is finalized. And then we will issue a final decision document. So I would like to point out that if you go to this website where the ANPR is published in the Federal Register, it does say that the comment period was closed on August 27, 2010. However, I had checked with the person in charge of this project, and she said that she will accept comments. And so if you would like to submit comments, please go to the Federal Register and follow the instruction to submit further comments. And here's just where you can obtain information on the study that I just presented. We've also, on this webpage, we've also have information on how we are responding to the petition from the Friends of the Earth. And the next slide is my contact information. Thank you very much.
Thank you.